Welcome to part 2 of our series on all things voltage droop. In the previous video, we covered what is voltage droop and why it matters. Today, we will be starting with the basics of an integrated droop response system for droop detection and response. An effective integrated droop response system must first detect a droop event. It must then address the droop to prevent timing failures in the system. This diagram illustrates the system logic we will monitor for VDD. The droop detector, responsible for sensing droop events, works in tandem with an adaptive clock generator that adjusts the system clock frequency during a droop event to protect system timing. The droop detector and adaptive clock generator work in tandem, with the generator supplying an independent clock to the digital droop detector. If a droop occurs, the detector sends a droop code to the adaptive clock, which then adjusts the system clock for the core logics, based upon the severity of the droop. This adjustment is necessary to minimize the performance impact of reducing the frequency. Constructing and assembling these components is only part of the challenge. It's crucial to test the quality of your droop response system using a droop injector. In fact, creating the capability to inject droops for testing can be as complex, if not more so, than developing the detector itself. The injector, solely used for testing, can introduce various droop profiles to assess system response and ensure there are no timing lapses or system failures. At this point, you might be asking if you should use an integrated droop response system versus a decoupled one. An integrated system from a single vendor reduces total adapt time, which is the sum of detection plus response times. It also ensures the system can respond intelligently with sophisticated droop telemetry. We take integrated droop response systems a step further by providing the industry's fastest adapt time for maximum energy efficiency, multi-threshold detection for fine-grained droop response, and in-field programmability for your customers' dynamic workloads. Join us next week for the final part of our series where we discover how to reduce voltage margins and avoid unexpected